One of the central dogmas of chemistry and science is something that you've probably heard before, that mass is conserved. Meaning, it cannot be created nor destroyed. Can't make mass, can't destroy mass. Has to go somewhere. We can see that in chemistry in chemical reactions. One reaction that you have done before is magnesium solid, so magnesium metal, mixed with HCl. Let's examine the particulate model of this so that we can write a chemical equation. So here I have magnesium solid, represented by my gray block here, with two valences, and I have my HCl, which we have our chlorine on top and our hydrogen on the bottom. And if these do a reaction together, they will make magnesium chloride, hydrogen gas. As you've seen in the particulate model, magnesium will react with HCl, hydrochloric acid, which is aqueous. As we've seen in the lab, it's dissolved in water. And that will form magnesium chloride, which is also aqueous, which we can find on our periodic table, and hydrogen gas. So when we say that mass is conserved, that means if I add up the mass of everything on this side of the chemical equation, so all of the reactants that I put in, it should equal the mass of all of the products, because the mass can't go nowhere. When we take magnesium and HCl and put them together and we rearrange them and make new elements, all of those atoms have to be accounted for, and so does their mass. So we can check this by adding up the mass of all of our elements. So one magnesium weighs 24 grams. One hydrogen weighs 1 gram. And one chlorine weighs 35 grams. If we add all that up together, we get 60 grams. And then we can do the same on the other side. If we have properly represented our chemical reaction here in our chemical equation, then the mass on the product side should also be 60. That's how we know mass has been conserved. So 24 plus 2 chlorines, so that's 35 twice, plus 1 gram for one hydrogen and 1 gram for the other hydrogen. And if we add all this up together, we end up with 96. So you may be asking yourself, why aren't they the same? And this has to do with the fact that I have not balanced my chemical equation. I have not accounted for all of the atoms. So now that I've balanced my chemical equation, we can redo the mass on the reactant side. This is the reactant side. This is the product side. These are all the things I start with. These are all the things I end up with. So I can redo the mass on the reactant side and hope that we get 96. So I still only have one magnesium, so 24. But now I have 2 HCl molecules, meaning I have 2 hydrogens. So that's 2 grams total. And I have 2 chlorines, 35 and 35. Have to account for both of them. Now when I add them all together, I do get 96 grams. And my mass is conserved. From one side to the other, from reactants to products, all of the mass has been accounted for. When you're balancing chemical equations, conservation of mass can help you verify that you have properly balanced your chemical equation.